Welcome back to the Deep Dive. Today we are wrestling with a problem that really determines whether your budget is a work of genius or, well, a piece of fiction. We're plunging into the world of mixed costs.
That's right. If you look at any business's expense ledger, you'll realize pretty quickly that very few costs are perfectly fixed, like, say, a simple rent payment.
Right. Or perfectly variable, like raw materials for just one widget.
Exactly.
Yeah.
Most costs are a mix.
The classic example is always the utility bill, right?
Yeah.
Maybe electricity, you have a fixed base charge just to keep the lights on, but then the total cost just spirals up based on how much you run the heavy machinery.
And that sort of, that fixed plus variable nature is really confusing if you're trying to predict next quarter's expenses.
Or, and this is crucial, if you want to understand how a change in your production volume is going to impact your profit margin.
And that leads directly to the manager's problem. We have to separate those fixed and variable parts. The entire backbone of strategic financial planning, especially something called cost volume profit analysis or CVP, it all depends on it. CVP is just so essential. It lets you model exactly how every dollar of sales converts into profit. But that whole foundation just collapses if you don't know your true fixed floor.
Or your precise variable cost per unit of activity. You can't calculate a reliable contribution margin if you're just working with a messy total cost number. So we've got some data here on electricity costs and production hours, and our mission today is to unpack two essential but vastly different estimation tools.
The high-low method and the Scattergraph method.
And we're going to see exactly how they approach separating these costs. It's really a conflict between speed and maybe visual truth. Okay, let's unpack this. Let's start with the favorite of anyone who needs a quick answer and, well, loves objectivity, the high-low method. This thing is famous for its simplicity.
It is. It relies on only two numbers, the highest and lowest levels of activity during the period you're looking at.
It's kind of the managerial equivalent of ignoring the weather forecast for the whole week and just drawing a straight line between Monday's low and Friday's high.
Yeah, and just assuming everything in the middle behaves in that same straight line.
Exactly. So we're using this electricity cost data. We anchor our calculation on direct labor hours. That's our activity driver.
Okay.
Looking at our data, the low point was in February. That was 6,000 hours, costing $60,000. The high point was in May. 18,000 hours costing $120,000.
Just those 2 points. Nothing else matters for this method.
The first step is calculating the variable cost rate, which is, just finding the slope of the line, your rise over run.
Right. So we look at the change in cost, the rise, and divide it by the change in activity, the run.
And that change in cost is $60,000. It went from 60,000 up to 120.
And the change in activity is 12,000 hours. From 6,000 to 18,000. This is where it's purely objective, just math.
So we divide that $60,000 cost change by the 12,000 hour activity change, and we get a clean, definitive $5 per direct labor hour. That's our variable cost.
And once you have that $5 price tag for every hour, finding the fixed cost is, well, it's just simple algebra.
Let's use the high point in May. Total cost was $120,000.
Okay, and we know 90,000 of that was variable. That's the $5 times the 18,000 hours.
So you subtract that variable portion from the total, and you are left with a fixed cost of $30,000.
And you can and should check it with the low point, too. It gives you the same $30,000, so the math works out.
So the equation is total cost equals $30,000 plus $5 times direct labor hours. Simple.
The math is clear, yes. But the real takeaway here isn't the number itself, but what this method forces us to just completely ignore about all the other months.
Right.
It connects only two dots. It creates this perfectly straight line and just assumes cost behavior is perfectly linear between those two extremes. It's objective, but that simplicity is, both its main advantage and its major conceptual flaw.
So the high-low method gave us a very objective answer, a precise $30,000 fixed cost. But is it the right answer?
That's the question.
To check that, we have to kind of ditch the rigid two-point calculation and switch to pure visualization, the scatter graph.
Yeah, and unlike high-low, the scatter graph uses all the data points, January, February, March, all 6 months, to create a visual picture of the cost behavior.
You plot all 6 points, you get this cloud of data, and then you have to visually estimate a line of best fit right through the center of that cloud.
It's an estimation, right? It tries to minimize the distance between the line and all the points, not just the two at the very ends.
And when analysts did that with the same electricity data, the results, well, they shifted quite a bit.
They really did. The high-low gave us $30,000 fixed and $5 variable. The scatter graph, using all the data, estimates the fixed cost is actually higher at $40,000.
But the variable rate is lower.
It's lower, yeah. $4.29 per hour.
Okay, here's where it gets really interesting. Visually, the scattergraph line is less steep because of that lower variable cost, but it starts higher up on the graph. It crosses the cost axis at $40,000.
A higher y-intercept.
So if I'm a manager signing off on next year's budget, which fixed cost do I bet on? Why is there a $10,000 difference?
And that difference really highlights the philosophical split here. High-low is all about the extremes. Scattergraph is about the central tendency.
The average behavior.
Exactly. The middle points, like March, which was at 12,000 hours, they're clearly pulling that true line higher than what the low point alone suggested. The scattergraph is more representative.
So let's test this. Let's see how much the predictions differ. Say we want to predict the cost for a typical month, maybe 10,000 direct labor hours.
Okay. The high-low equation, that's $30,000 fixed plus $5 an hour. It predicts a total cost of $80,000.
And the scattergraph equation, the $40,000 fixed plus $4.29 an hour.
That predicts a slightly higher cost, $82,900.
So a difference of about $2,900.
Yeah, which is about 3.6% for, a preliminary managerial estimate that's reasonable close. The good news here is that in this specific example, the high and low points were actually pretty representative of the overall trend.
But that doesn't always happen.
No, it absolutely does not.
And that brings us to our second practice problem with monthly production costs, where the two methods just completely disagree. What happens when those data points are not representative?
This is such a great teaching moment. It's about the danger of relying purely on an objective calculation without looking at the picture.
So in this new data set for production costs, the results are all over the place.
Dramatically different. The Scattergraph method estimates fixed costs at a very low $150 and variable costs at $26.88 per unit.
But then the high-low method, it just flips that entirely.
Yeah.
The fixed costs shoot way up to $3.28.
More than double.
And the variable rate drops to $24.29 per unit. We're not talking about a small 3.6% difference anymore. This is a complete structural failure in the estimation.
And this raises the critical question, why? Why such a massive divergence, especially in those fixed cost estimates?
The answer is in the visual. You have to look at the graph.
You do. If you plot this data, most of the production months, they cluster really tightly between 45 and 70 units.
Right, but the high-low method doesn't care about the cluster. It's forced to use the extremes. 75 units for the high and 40 units for the low.
And that 40-unit point is the culprit.
It's an outlier.
It is clearly an outlier. Maybe February was a month with a plant shut down for maintenance or a key supplier was late. Something abnormal happened.
And the high-low method blindly connects the normal high point to this one single abnormal low point.
And that line it draws does not reflect the typical month-to-month relationship for the main cluster of data at all. It's completely distorted.
The danger here for a manager is just catastrophic. If you trust that mathematically derived high-low fixed cost of $328, you might drastically overestimate your company's break-even point.
Or you might set your product's price too high because you think your fixed costs are eating up more resources than they actually are. The calculation completely hides the operational reality of that one bad month.
It's so important. If that 40-unit month was a one-off event, drawing a line through it just violates the core assumption of the whole analysis.
Exactly. The analysis has to be done within the relevant range of normal activity. High-low is just extremely sensitive to these outliers.
So a key takeaway for anyone using this: you have to visually inspect the scatter graph first. Make sure your highest and lowest activity points actually look like they belong with the rest of the data.
Yes, they have to be representative of normal, repeatable operations. Otherwise, the method is garbage in, garbage out.
Okay, now that we've seen the mechanics and the potential pitfalls, let's pivot a bit. Let's focus on the managerial side of this. Why do we even go through this effort?
That is the real question. It's because separating costs is the essential first step toward any kind of strategic decision-making. Managers aren't asking which equation is perfectly correct down to the penny.
No, they're asking, what does the range of these estimates tell me about my cost structure?
And what's my maximum risk on my fixed cost floor? That's what they need to know.
The ultimate goal here is forecasting and control. Just knowing that your fixed floor is somewhere between $30,000 and $40,000, that is powerful intelligence.
It's so much better than just looking at the total monthly bill, which tells you almost nothing about the underlying behavior. If you budget for $40,000 in fixed costs, you're building in a margin of safety.
And that range itself is valuable information. When the results are close, like in our electricity example, You gain confidence.
Right. You know your cost behavior is stable and reasonably linear. You can pretty much use either method to get a quick answer.
Which really speaks to the good enough principle in business, right? The goal isn't perfect information. It's timely and directionally correct information.
Exactly. High-low is perfect for that. When you need a quick snapshot or a preliminary analysis because it's fast, simple, objective.
But you must use the scatter graph when you need detailed budgeting, or when you really need to visualize trends and spot those dangerous outliers.
It just gives you a far better understanding of the overall cost behavior because it forces you to look at the whole picture, not just 2 points in time.
And when the results are wildly different, like in our production example,
That divergence itself isn't a failure of the models. It's a critical diagnostic signal. It's a big red flag.
it tells the manager, stop. Do not use either of these estimates yet.
You have to go investigate why that low activity month was so weird. It signals the need for more analysis, maybe even moving beyond these simpler tools.
So really, using both methods and comparing them gives you better information to make a better decision.
Absolutely.
Okay, so we've established high-low gives you a quick objective snapshot of the extremes, while the scatter graph gives you a fuller visual picture of the typical cost landscape.
And that really wraps up the core philosophy here. In managerial accounting, we are almost always dealing with estimates derived from historical data. The value is not in getting a single perfect number.
Right.
It's in gaining enough understanding of cost behavior, separating that fixed base from the variable driver to make informed, risk-adjusted decisions on things like budgeting, pricing, and cost control.
So what does this all mean for you? Before this deep dive, you just had a single total monthly bill for electricity. It's just one number.
A confusing number.
After applying these tools, you now understand that your cost has a fixed, predictable floor, probably between $30,000 and $40,000, and a variable cost driver that's predictably running between $4 and $5 per hour.
That is operational intelligence you can actually use to run your business better.
And that leads to a final thought for you to explore on your own. Both the high-low and the scattergraph methods, for all their utility, are ultimately just approximations of the most precise technique out there.
Which is statistical regression analysis.
Exactly. While regression is more complicated, that $10,000 divergence we saw in the fixed costs between our two simple methods, that really highlights that sometimes for truly critical long-term decisions, the added mathematical rigor of statistics is the natural next step to perfect your understanding of cost behavior.